Alright, this is our third example on complex derivatives. And remember I said that it's a complex derivative when you have multiple rules in one function. Last time we looked at, for example 1, we had a rule within a rule, a product rule within a quotient rule. What makes this complex is you have basically the product rule twice. Okay, you have three components here. You have x squared, you have sine of x as another function, and then you have e to the x. And so it's not just a simple product rule. You have three functions that are being multiplied, so you have to take that into account. Now there's two ways to do this problem actually. We can consider this first part, x squared sine of x, as one component and e to the x as our second function g, or we could group sine of x and e to the x and basically do x squared first. It's going to work either way, just make sure you label your components and are consistent with them. So first step is to make the derivative easier. So what I'm going to do is just break it up into a multiplication problem as I showed you before, where we have three components, and we'll go from there. We're going to use the product rule, and then we're going to use the product rule again. That's step 2, determine what the rules are we're going to use. So we're going to use the product rule twice. So as I said, you can actually break this problem down two different ways. Since I looked at just the first two functions, I might as well call that A. So this bigger set of brackets I'm going to call A. This right over here I'm going to call B. And then the subcomponents of A, x squared and sine to the x, I'm going to call C and D. Again, you could have actually called x squared A and then sine of x times e to the x B, and you would have got the same answer. But again, we're breaking it down into components from biggest to smallest, and then we're going to take the derivative backwards as we did on the previous example. So here we go. A is x squared sine of x, C is x squared, B is e to the x, D is sine of x. The derivative, and again, for step 5, when you take the derivatives, you do it in the reverse order, you go backwards in the alphabet. So we're going to start with our component D. D was sine of x, the derivative of sine is cosine. C is x squared, the derivative of that is 2x. B is e to the x. The derivative of that is obviously e to the x, the only derivative that's equal to itself. So to figure out the derivative of A, that's why we did the derivatives in reverse order, because A is composed of both C and D. And now we have the derivative of C and D, which we use in the power rule. So A prime is equal to C prime D plus CD prime. So it's going to 2x times sine of x plus x squared times cosine of x. Really no simplification involved there. You can just kind of remove the brackets and that's it. So it's 2x sine of x plus x squared cosine of x. And now when we go back to our function, think about this. Since we labeled this A and B, the product rule still holds. It's A prime B plus AB prime, and that's why we figured out A prime. Now we can just plug this into the formula for our bigger product rule. So here's our A prime we just found. B is obviously e to the x, plus A, which is just right here, plus B prime. And remember, B prime is the derivative itself, which is e to the x. You can start to see why we do the steps the way we do. Find the derivatives in reverse order because it always gives you the right answer. Now, is there any simplification we can do here? Well, yes, both of these have an e to the x, right? So we can actually pull that e to the x all the way out to the front. In fact, let me just show that with an arrow real quick. So both of these e to the x's are going to get pulled out to the front, pulling out a GCF. And then on this last slide, you'll see the final step. We have e to the x on the outside, times whatever's left on the inside, which has three components. It looks to me, actually, now that I see this, you could also pull an x out. Let me see if I can do that real quick. Okay, so when you pull that x out of each of these components, you'll pull it out here, and then you're left with 2 sine of x plus x cosine of x plus x sine of x. There's nothing else to pull out. That's it for example 3. That's it for right now for my examples for complex derivatives. If you have any other questions about solving these complex derivatives out, labeling your components, and finding the derivative of them, let me know.